All right, here we go. So we're going to do 9.5. Now, 9.5 is broken up in 2 days. So today is the information plus a little bit of homework. 9.5b will be a practice day. So I'll do a quick reteaching of what's on here. So it'll sound very similar. And then there's a worksheet for 9.5b. And that was given in the email. All right, here's your homework. All right, here we go. So inscribed angle. Ooh, a new type of angle today. All right, so many concepts today. Everything is fairly straightforward, and I would dare say easy, but there's a lot of it. There's 5 basic shapes, and when I put all 5 together, it can be slightly confusing, so take great notes, pay attention, and ask questions if necessary. All right, remember the rest of the chapter is kind of like that. It's a lot coming at you. So recall that we've been dealing with circles, and if I make an angle coming from the center of a circle, it makes an arc AB here, and angle 1's relationship to arc AB is that they're both equal. The central angle 1 is equal in degrees to the arc AB. They're one and the same. All right, so here comes the new stuff. Here's the first idea. So make an angle, but this time we're not going to make a central angle. This time we're going to put the vertex on the circle. And when we put the vertex on the circle, that ain't a central angle. Angle 1 is not a central angle. It doesn't come from the center. It comes from a vertex that's on the circle. We had this word already at the beginning of the chapter. We called this inscribed, an inscribed angle. So first vocabulary word, right? Inscribed angle. That's an angle whose vertex is on a circle, and the sides, the black portions there, are chords of the circle. Okay, so there's an inscribed minor arc, and there's an inscribed major arc. All right, recall, once again, the relationship between central angle and arc are one and the same in degrees. Angle 1 is equal to arc AB. Not the same for inscribed angles. So it's kind of hard to get an idea from this picture, but what would be the relationship between the inscribed angle B, or ABC, and arc AC? What would go right there in the middle? Okay, so let's do a proof and figure it out. So I'm going to prove that it turns out the relationship between the inscribed angle and the arc is that the angle is half of the arc. The angle is half the arc. The angle is half the arc. All right, so let's prove this puppy. All right, so there's my given. I need to get way down there to the bottom so that angle ABC is equal to half of the arc. All right, so the first thing I'm going to do is always we're going to make triangles. So I'm going to not connect A to C. I'm going to connect O to A. Well, it's just basic construction. Let's see. OA and OB are both now radii, so therefore they're congruent. So tick mark, tick mark. And if I have 2 tick marks there, well, that means it's it's an isosceles triangle. What do we know about isosceles triangle? We know that the angles opposite the 2 congruent sides are also congruent. So therefore, angle AB, I called it ABC instead of ABO. Look at the very bottom where we're going. We need on the left side, we need angle ABC. So instead of calling it ABO, I'm going to say angle ABC is equal to angle BAO. That's the kind of the one we were expecting. We weren't expecting ABC, we were expecting ABO, but same angle. All right, so tick or arc, because those 2 are congruent. Now I'm going to reach way back to chapter 3, or maybe it was chapter 4, where we had triangles and external angles. Look at the triangle there. We have external angle AOC. And angle AOC, since it's an external angle of the triangle, is equal to the sum of the 2 remote interior angles. So that would be angle A and angle B. So if I add up angle A and angle B, I get angle AOC. I'm just going to call, they're both congruent, so I'm just going to say 2 either angle A's or 2 either angle B's is equal to AOC. All right, and remember, angle A is angle A. All right. But angle A is equal to angle B. So therefore, angle ABC is also 2. Now, if I divide both sides by 2, once again, angle A and angle B are exactly the same. So if I divide both sides by 2, I get angle ABC is equal to 1/2. I mean, all I did was divide both sides by 2. And you're like, you changed A to ABC. Well, angle A is the same as angle B, and angle B could be called ABC. All right, that's just division. Ooh, it looks pretty close. It says angle AOC, and I needed to have it to say arc AC. Well, lucky for us, look where angle AOC is. Angle AOC is a central angle that creates arc AC, and the relationship between central angle and arc are they're one and the same. So I can they're equal to each other, right? So I can do a quick substitution. QED, I'm done on that sucker. All right, so what did I just prove? I proved the relationship between the inscribed angle and the arc, and that's theorem 9.7. And it says the following. I don't care how you draw the inscribed. There's 3 different ways of drawing an inscribed angle. However you draw the inscribed angle, then angle ABC, or I could just say angle B, is equal to 1/2 of the arc it makes. So the definition says the measure of the inscribed angle of a circle is equal to 1/2 of its intercepted arc. That means the arc it makes. All right, there's 1 of 5. So hard to remember which one is half, though. Is it the angle that's half, or is it the arc that's half? Here's how I remember it. So I just think of a circle and make a semicircle or a diameter, and I make an inscribed angle. I can put C anywhere on the top or bottom, and if I connect C to A and B, well, it's kind of clear that that angle is 90. Now, I'm just not claiming it's 90. I'm saying, well, using theorem 9.7, we know that the angle is equal to 1/2 of the arc, and arc AB, which is a semicircle, more formally, I should say ACB, since I got to use 3 letters, is equal to 180 degrees. 1/2 of 180 is 90. So that's how I remember which one to take 1/2 of. Don't take 1/2 of the angle, take 1/2 of the arc. All right. So I'm going to show you one. It's messy, but it's not too bad. All right, that's a messy picture right there. Let's see what's going on here. So it says find the value of X and Y. Well, X and Y are both red. But if I get rid of all the things in blue there and just look at the things in red, well, I can see that I have an inscribed angle T, that's the X value, and it makes arc PQ, and arc PQ is 40, and we know that the angle is 1/2 of the arc, therefore X has got to be 20. Now look at the blue. Well, the blue is kind of like the reverse there. I'm told the angle is 50, so therefore the arc wouldn't be 1/2 of 50, it will be double 50. In other words, PQR or PR would be 100, but let's see, PQ is listed as 40, so Y would be 100 minus 40. In other words, Y would be 60 degrees. And there you go. There's a messy thing. It turns out that's pretty simple. So shape number 1, inscribed angle. The angle is 1/2 of the arc it makes. All right, next idea. Number 2, circle, inscribed angle, and whoa, we got a second angle, but what do you notice about it? Well, what I notice about it is that both angles are making exactly the same arc. It's not labeled there, but look, both angles make exactly the same arc. Well, if they make the same arc, then that means both angles, yeah, they have to be congruent. This is corollary 1 to 9.7. And it basically states the following. If that you have 2 arcs or 2 angles that intercept exactly the same arc, in other words, they form the same arc, well, then the 2 angles have to be congruent. 2 angles have to be both inscribed. You can't have a central angle and an inscribed angle. So both angles must be inscribed angles. They both must make the same arc. Look, both the red one and the blue one there make arc AB. Therefore, 1 is congruent to 2. Second shape. All right, next shape, number 3, circle, semicircle, and I'm literally going to use the thing I just showed you how I remember which one to take 1/2 of. So it's this thing that if you start with a diameter or a semicircle and you make an inscribed angle, it doesn't matter where that C is, as long as C isn't on A or B. But if C is anywhere along the circle, anywhere, then it makes a 90-degree angle. It's inscribed. And the arc that it inscribes is 180 degrees, therefore 1/2 of 180 is 90. And that is corollary 2. So our third shape looks like that. And the result is that the angle has to be 1/2 of the semicircle. In other words, the angle has to be 90 degrees. I told you these would come at you fast. All right, Not the last shape, but the last one that's a corollary. All right, so think about it's a circle. Yes, I get it. Ooh, it says draw a quadrilateral. So I want you to draw it so it's inscribed. So if you try to draw, let's say we pick a rectangle, yep, we can inscribe it. In other words, all the vertices touch the circle. Try to draw a square, yep, it works. Trapezoid, it can work. There's a quadrilateral. If you try to draw a rhombus won't fit. But I'm just going to draw just a general one right there. So this is going to be the last corollary of 9-7. It states the following. I want you to look at opposite angles of the quadrilateral. So for instance, H and F. And if you look at angle H, it's inscribed, and it makes arc GE or GFE. And if you look at angle the opposite to H, which is F, it makes GE as well too. It's a major, so technically GHE. But look, it completes the entire circle. If you pick opposite angles and look at the arcs it makes reciprocal arcs of each other. In other words, not necessarily cuts the circle in half, but breaks it into two parts. Okay, so if that's the case, and the inscribed angle is half, well, half of 360, that's the full circle, would be 180. And we say any two angles that add up to 180 are supplementary. Therefore, that's the idea, is that if you have an inscribed quadrilateral in a circle, then opposite angles are supplementary. In other words, they add up to 180 degrees. All right, so that's our fourth one. We better do a problem involving inscribed quadrilateral. So the black portion right there, look at inscribed quadrilateral, and then you got these diagonals that are in blue. And I got three questions there: angle BCA, angle ABC, and angle BAD. So maybe one little piece at a time. Let's look at angle BCA. BCA. If I look at angle BCA, angle BCA it's got to be equal to angle BDA. Now, where am I getting that from? Trace BCA, right? And it makes the arc AB. And if I trace the angle BDA, it makes the arc BA as well too. And look at where that arc is coming from. It's coming from angle 40, the inscribed angle 40. And then we know that the arc is double the inscribed angle, so therefore it's got to be 80 degrees is arc AB, but they're not asking me for the arc AB. They're asking me for the angles. So if two inscribed angles make the same arc, then those two angles are equal. So 80 isn't the answer. They're not looking for the arc. They're looking for the angle. So angle BDA is 40 and angle BCA are also 40 because they make the same arc AB, and BDA is labeled as 40. All right, first one down. Now we do ABC. Let's see, where is ABC? Oh, ABC. Oh, look, it makes a diameter. Look at inscribed angle ABC. It makes arc ADC, and that is a semicircle. And we know that anytime an inscribed angle makes a semicircle, then the answer is 90 degrees. The last one, BAD, a little bit harder to see. BAD. So let's see, BAD, right, would be made up of, well, the opposite side to BAD would be BCD. And why do I care about that? Because I got some information about a couple of those. So let's see, angle BCD, look at angle BCD. BCD is made up of, well, two pieces. One of them's listed as 30 degrees, but angle BCA is not listed. But look at the first thing. The first thing we already figured out, BCA. BCA was 40 degrees. Remember, we got that because of BAD or BDA was 40 degrees. So therefore, BCD is 70 degrees. And therefore, I can figure that out just by subtracting 70 from both sides. So BAD is 110 degrees. All right, that one was complicated. It wasn't as messy as some of the previous ones, but I think that one was the most complicated one. By the way, there were other ways of doing this one, but they all required a bunch of work. All right, I said 5 shapes, last shape. So think about this. So I got an inscribed angle T, and for some reason, point B is highlighted red. So think about this. So if that was the shape we have, then let's see, angle T would be equal to half of arc AB. Now let's move point B closer to T. I've moved it a little bit closer. Does that change the formula? No, it's still an inscribed angle. Let's move B even closer, right? Would that change the formula? The answer is no. If I move B so close to T that it actually was T, suspiciously, now B is no longer on the shape. B is T. T suspiciously called T because T is now a tangent. The question is, would the formula change? And the answer is no, of course it wouldn't, right? As long as it's formed in this way, that you have a chord, AT, and you have a tangent, the formula would remain the same. The only difference is I don't have an arc AB any longer, right? I have an arc AT. So the only difference is that AB is now AT, right? So if you have a tangent to a chord on a circle, then that it's not an inscribed angle anymore, right? But that angle formed, angle T, we'll call it, is still equal to the same thing, a half of the arc it makes. Now, caution, you're probably wanting to say immediately it's 90 degrees, right? And remember, we have that thing that if it's a diameter or a radius and it goes to a tangent, it forms 90 degrees. But look where point A is. Point A is to the right of where the center is. So therefore, we don't have a radius or a diameter. Therefore, this angle T is going to be less than 90 degrees, but probably pretty darn close. If I move A to the left side, it'll be more than 90 degrees. All right, that's our last shape right there. All right, so here's an example. Once again, these are all easily done individually. So let's see, I got a tangent. So how big is angle ATP or just angle T? Well, it's got to be half of the arc. In other words, it's got to be 70 degrees. Not a very overwhelming concept. We had 5 shapes today. So we're going to do homework tonight. So our goal is to make it through this homework. And then next class, we're going to get a worksheet where we're just going to hammer you on all 5 shapes so you get plenty of practice. And then we'll move to 9-6 and get a bunch more. All right, so that'll do it for today. I'm not sure if we're on camera. I'm send you another email. I probably already have the answer by the time that you have this, but I'm probably going to ask you where you're at. I don't know if we're off a day or on a day or whatever, but it's fine wherever it asks. We're making really good progress. We'll finish by May. All right, so that'll do it for today. Have a great day, and I'll see you tomorrow.